here we are told that the given equation is a separable equation, and that we can see that they are made of trigonometric functions. And just to recall, when we say that the equation is separable, we can group all the x's together and we can group all the y's together. And that there is a way of writing the function or the equation such that all the x's and all the y's do not mix with each other. And in this case, it is beneficial to write the equation in differential form. So I'm just going to rewrite that before we write them in differential form. And so it's minus sine x sine y and cosine x cosine y. I'm just going to write y prime as dy dx. That way we can see clearly that we can actually group the x's together and the y's together by just doing the mnemonic multiplication. And let's just do that. Here I'm gonna retain the x's on this side, and I'm gonna put the y's on the other side. And so on the other side it looks like this. And now we have already grouped the variables. So on this side are all x's, on this side are all y's. And now we just have to notice that in fact we can do a substitution. Well, that would be a simpler thing to do, is to do a substitution. Or we can just notice that in fact the derivative of cosine is sine x. And so we know that the derivative of cosine x, or the differential of cosine x, is actually negative sine x dx. We know that, right? And also here on this side, we also know that the differential of sine y rather, is cosine y dy. So just to recall, to get the differential of this, we just get the derivative of cosine, which is negative sine x, and then attach the dx. That's the variable here. And the same is true on this side. We just get the derivative of sine y, which is cosine y. We attached the dy, the differential of y. And now we can rewrite our equation in this way. We can write minus d. Here we have cosine of x. And here we have cosine of x. And on this side, we have d sine of y. And here we have sine of y. Look at that. You look at that, and that's actually in the form du over u, right? And here's our u here, here's our u. And we know the integral of that. That is just c minus ln of cosine x. And on the other side, that's just ln of sine y. And just to remove the logarithms, we can actually use both sides as exponent to the natural number e. And when we do that, we get e raised to the c minus ln cosine x. On this side, e ln sine y. And because ln and e are just inverses of each other, we can just remove the ln's and e's, and we will have e minus ln cosine x. Here we have just sine y. Okay, we can simplify this further. That becomes just e to the c e to the ln cosine x raised to the minus 1 sine y. Now we have, so I'll just call this c, and this bit here just becomes 1 over cosine x. You have sine y on the other side. And this could be your solution, or you might want to write it without the denominator, so that becomes c secant of x equals sine y.